Redux is a state management library that helps manage and centralize application state. While it is most commonly used with React, it is actually library agnostic, meaning it can be used with other frameworks as well. The primary reason to use Redux is to manage complex state logic outside of components. This is especially useful in large applications where multiple components need to share data. Redux provides a single source of truth through a centralized store, which improves predictability and makes debugging easier, particularly with the help of developer tools. Redux operates on three core principles. First, it maintains a single source of truth, where the entire application state is stored in a single object within one store. Second, the state is read-only, meaning it cannot be modified directly. Changes can only occur through actions. Third, all state changes are handled by pure functions called reducers, which specify how the state should change in response to actions. Key concepts in Redux include the store, which holds the state, actions, which are plain JavaScript objects describing what happened, reducers, which are pure functions that take the current state and an action to return a new state, dispatch, which sends actions to the reducer, selectors, which are functions used to extract specific data from the store, and middleware, which handles side effects like API calls using tools such as Redux Thunk or Redux Saga. The Redux flow can be summarized as follows. A user interaction triggers an action, which is dispatched to the reducer. The reducer processes the action and returns a new state, which causes the UI to re-render with the updated state. To integrate Redux with React, you can use the React Redux library. This involves wrapping your app with a provider component to connect it to the Redux store. The useSelector hook allows you to access state, while the useDispatch hook lets you send actions. Modern Redux, often implemented using Redux Toolkit or RTK, is the recommended way to write Redux logic. RTK reduces boilerplate code and provides utilities such as createSlice, which combines action creators and reduces, and createAsync Thunk, which simplifies asynchronous logic. This approach results in cleaner and more concise syntax. However, Redux is not always necessary. For small applications or when managing simple component state, alternatives like the context API or React hooks such as useState and useReducer may suffice. The benefits of Redux include centralized state management, predictable state transitions, easy debugging with features like time travel debugging, and a scalable architecture. Common middleware options include Redux Thunk for handling asynchronous logic, Redux Saga for managing side effects using generator functions, and Logger for logging actions and state changes during development. To ensure best practices, keep your reducer functions pure and avoid deeply nested state structures by normalizing your state shape. This will help maintain a clean and efficient Redux implementation. When working with state management, it's important to avoid putting non-serializable values in your state. This ensures better predictability in debugging. To simplify your Redux setup, consider using Redux Toolkit, which reduces boilerplate and streamlines configuration. Additionally, leverage selectors to avoid tight coupling to the state shape, making your code more maintainable and scalable. Now, let's compare Redux and the context API. Redux is best suited for state management in large applications with complex state flows. It enforces a strict unidirectional data flow, offers excellent dev tool support, and provides built-in performance optimizations through tools like Connect and selectors. Middleware support in Redux, such as Thunk or Saga, makes handling asynchronous operations seamless. However, it does come with a moderate to high learning curve and more boilerplate. though this is mitigated by Redux Toolkit. On the other hand, the context API is ideal for solving prop drilling issues in smaller, simpler applications. It also enforces a unidirectional data flow but lacks built-in async support and robust dev tools. While it has minimal boilerplate and is easy to learn, it may cause unnecessary re-renders if not optimized and is less suited for complex state sharing. So, when should you use each? Use the context API when you need to share static or lightweight state, such as theme or authentication status, and when state changes are infrequent. It's also a good choice if you want to avoid adding extra libraries. Use Redux when your app state is large, shared, or complex, and when you need middleware, async handling, or advanced debugging tools. Redux is also the better choice when state transitions need to be predictable and testable.